Good day, students. You are welcome to the National Open University of Nigeria practical class powered by the Department of Science Education. This course is SCD 305, Practicum in Science Teaching. Our focus shall be on physics practical for physics education students. My name is Dr. Amusa Oluwadamilare, one of your facilitators for physics practicals. At the end of this practical class, you should be able to do the following. 1. Stage and conduct simple pendulum experiments. Determine the value of period t and t square for a given number of oscillations. Plot a graph of t square against L, the length of the pendulums. And also determine from your graph the slope s and the intercept on the t square axis. Use your value of s, that is slope, to determine the value of acceleration due to gravity. Important keywords in this practical class include pendulum bob, oscillation, periods, acceleration due to gravity. One of the fundamental topics in physics at the secondary school level is concept of motion. You are aware that there are 4 types of motion. They are random motion, translational motion, rotational or circular motion, and lastly, oscillatory or harmonic motion. Simple pendulum experiments can be categorized under oscillatory or harmonic motion. It is simply to and fro motion. This experiment is premised on the mathematical expression t is equals to 2 pi into the square root of L over G. When you change the formula of expression, it can give you t square is equals to 4 pi square L over G, as you can see on the screen. T square is directly proportional to the length of the pendulum. With this background, we can start the experiment by identifying the apparatus. We have pendulum bob, little stand and clamp, split cork. You need stopwatch or stop clock. You need a thread and a meter rule. We can now start the experiment in full. Now we are at the practical class. We have some of the apparatus here, the little stand. We have our clamp, you can see, and you have the cork, split cork. So you can divide it into 2 so that your thread can move through the split cork. The split cork will be fixed into the clamp, through which your thread, will be tightened. You're going to make use of this clock. It could be stopwatch or stop clock. This is stop clock. We're also going to make use of meter rule. As you can see, these are very, very essential for this experiment. For your convenience, you can prepare your recording sheet that will show the various lengths of pendulum you want to make use of. I'm going to work on length 60. The length of my pendulum for this experiment is going to be length 60. So I will charge you to make use of other length 50, 70, 80, and 90. So I'm taking the measurement. You start from point 0. Make sure your point 0 is very close, tightened to the cork. And look at the measurement here. This is 60. And the line 60 should be at the middle part of the pendulum bob so that you can get the accurate length. So having measured length 60, you set to put the pendulum bob at a convenient angle. You stay by the side so as to prevent the pendulum bob from dangling so much. Now, this side of the stop clock, this side is for making it, you put it in motion. The clock is already reading. If you want to stop, you press it down. The other handle here is to restore it back to the normal position. That is the function of that. Now let us start. My pendulum bob will be placed at a very small angle. You can see that. If I release it, then I press my stop clock to start. Let me put it on the table here for convenience purposes. Make sure you position your hand very well. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, so you can see you have 32 seconds. So you record it down. That's the first T1. That is. Then let's take this, do it for the second time. You repeat it because you have time 1, T1 and T2, then you find the T mean. Restore it back to the normal position. Let's take it again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you have, for the second time, you have 31. This is 31 seconds. You also record that. The initial time we have 32, we now have 31 seconds. By the time you compute the mean of this value, so it's going to give you 31.5. 31.5. With the aid of your calculator, you compute the period of oscillation, and period in capital T is going to give you T mean all over 20. T mean all over 20. So in this case now, you are going to have 31.5 all over 20. Also make use of a calculator to compute the T square. Now, as you can see on the screen, you are going to use this value to plot a graph. The graph of T square on the Y axis and the length of the pendulum on the X axis. Choose your very good scale, plot the graph. It's going to give you a straight line graph from the origin. Your graph is going to be a straight line graph, as you can see, from the origin. You calculate your slope. Use your y2 minus y1 all over x2 minus x1, as you can see. So this will assist you in plotting the graph very well and calculating the value of G. The slope will now be used in an expression, that is showed on the screen. The expression T square is equal to 4 pi square multiplied by L all over G. By the time you rework your calculation, the formula, you are going to have 4 pi square all over G multiplied by L. Remember, you have plotted the value of T square and L. The value of the expression 4 pi square all over g is the slope, in that expression. Use the value, that expression, and equate it to the value derived from the slope of your graph. You work it out, it's going to give the value of g. I want to urge you to repeat this experiment, complete other values for the length of the pendulum, and you are going to plot your own graph, work out your table, work out your slope. You are going to get the value. Your value should be around between 9.5 and 10 meter per second square. Till I see you in the next class, bye for now.